So what X-ray crystallography is, it's a technique for determining the structure of a material, specifically a crystal. You might think of a crystal as made up of millions of little bricks that are all the same size and shape. And what we're doing is hitting them with X-rays, and from the pattern that comes out, we can figure out not only what it's made of, but where all the atoms are and how they're connected.
Crystallography is used to make chemistry real. It's used to describe molecules that chemists have made.
What we actually get is a diffraction pattern when we hit the crystal with X-rays. This diffraction pattern can be analyzed by the software that comes with the instrument, and what we get out are, first of all, the elements in the compound, also how the atoms are bonded together to form molecules, and also how the molecules pack into this lattice. And from that, we can derive very accurate bond lengths, bond angles, and even absolute structures of how things are put together in biological substances.
The most exciting thing about crystallography is seeing for the first time before anybody else in the world the shape of a molecule to see what a molecule truly is. The crystallographer really is the first person to ever know exactly what this thing looks like.
As far as the highlights in the development of chemical crystallography over the history of our company, I think as well, development of two-dimensional detector technology. Always we've pioneered that. The multi-wire detectors were a revolution in protein crystallography in the 80s, and the two-dimensional CCD was a revolution in chemical crystallography in the 90s. We did not even perceive how good those detectors were going to be. And now we're in the midst of another revolution with the CMOS on the two-dimensional detectors. And all of these are embedded together with really fantastic software. The software is what makes all this interesting hardware work, although it's sometimes buried deep in the systems and people may not perceive how critical the role of the software is.
What's important if you're a customer is you first of all have to be able to solve your problems, and that means you have to collect extremely good data, but you also have to have an instrument that's very reliable. It doesn't have service issues, you don't have to change components by hand and these things, and it also has to be pretty straightforward to operate, and it has to give you publication quality data with a minimum of effort. So our newest generation of instruments from Bruker has tried to address all of these with a modular design of all of the components, a state-of-the-art new detector technology, and automated software which could be used for any kind of problem ranging from simple structures for undergraduate students to very complicated research problems in any of our laboratories around the world.
Bruker has really a great track record of being the technology leader. Bruker is considered to be the detector company, and when you look at detectors that have come out of this company, the Smart 1000 or the Smart 1K, one of the first commercial CCD detectors that are used in crystallography, and finally we brought CMOS to the market with all its advantages. So there's lots of innovation, exciting technology. When you look at Bruker instrumentation, they just give you best data, and that's in the end all that counts.